Okay, class, we're about to start on section 2-3, and I am about to go over the problems for you to see in relation to the homework. So I'm going to start off with problem number 3, and this is 3A on page 211. It says, a sextillion has 21 zeros. Write 3 sextillion in scientific notation. So since it has 21 zeros, we know it'll be times 10 to the 21st power. And they tell us to write 3 sextillion, so it'll be 3 times 10 to the 21st power. That would be A. Now we go here to B. The number, all right, let me see, that is millions, billions, trillions. I'm thinking that's quadrillion. Yeah, that's a quadrillion. The number 45 quadrillion is read 45 quadrillion. Write the number in scientific notation. So we know it's going to be 4.5 times 10 to some power. Now, if you look at this number here, there are 3, 6, 9, 12, 15 zeros plus the decimal that goes in between the 4 and the 5. So let me just write it out. Let me see. It was 15 zeros. Okay, so these are all the zeros. We have our decimal here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then we have to go to the 16th place. So it'd be 4.5 times 10 to the 16th power. Okay, now C, it says, write the number 9 times 10 to the 27th power in standard notation. The number will be read 9 octillion. So it's 27 zeros. So 1, 2, 3. 1, 2, 3. 1, 2, 3. That's a lot of zeros. It's 12, 15, 18, 21. I'll put the 9 here. So we need 6 more zeros. And that right here is your final answer. 27 zeros and a 9 in front. Okay, now we go to D here. Now with D, it says use scientific notation to divide 9 octillion, which is from C, which is at 9 times 10 to the 27th power, by 45 quadrillion, which is what we had here for B. So it'll be 4.5 times 10 to the 16th power. Now you have a couple ways you could do this. We could use Desmos, which would, yeah, let's try Desmos. All right, so we have 9, I'll put the division sign, come back up here, times 10 to the 27th power. And then in our denominator, it'll be 4.5 times 10 to the 16th power. And it gave us 2 times 10 to the 11th power. And that would be our final answer. Now, I showed you all how to do it in a calculator. Now I'm going to show you all how to do it by hand. So we take this same value here. What I like to do whenever I have a scientific notation divided by a scientific notation, I separate the values. So I have 9 over the 4.5 times 10 to the 27th over 10 to the 16th. Now 9 divided by 4.5 is just 2 times. Now 10 to the 27th over 10 to the 16th, they have the same base. So you will bring the base and then you will subtract the exponents, which is 27 minus 16. So it'll be 2 times 10 to the 11th power, which is what we got here with the calculator. So that's how you would do it by hand. Now the next problem would be problem number 5. 5A. It says the amount of federal acreage in the United States is approximately 6.35 times 10 to the 8th power. The total acreage in the United States is approximately 2.27 times 10 to the 9th. So A, it says use scientific notation to write the ratio of the federal acreage to the total acreage. So basically, we would take these two values and divide them by each other. So again, well, actually that's all they wanted. This is all they wanted for that problem. Now they want us to simplify the answer. So if we take our calculator, like I said, if you want to do it by hand, I showed you earlier how to do these problems by hand, or you could do it by the calculator. Times, what's that, 10 to the 8th power, divided by 2.27 times 10 to the 9th power. So now, if you notice here, we have this decimal, 0.279 and so on. So what you could do, if you move that decimal one place, that'll put in scientific notation. So it'd be 2.797935682819. Now you could have just rounded to a couple places, but I just wanted to write it all out. So it'd be times 10. We move that decimal one place to the right, so it'd be to the -1 power. All right. Now we go to our next problem, which is problem number 7. Problem number 7, we add 6 over x to the 0 power. So what this is saying is whatever 6 divided by x is, we'll take everything inside this parenthesis to the 0 power. And we know anything to the 0 power except 0 is 1. So 6 over x to the 0 power is just equal to 1. Now we go here to problem 11. Problem 11 is 4x to the -4 power. Now if you look here, the x is the only thing taken to the -4 power. So whenever we take a whole base to a negative power, all that does is bring that in the denominator. So this would be x to the 4th power in the denominator, and 4 will remain in the numerator. Now this would be your final answer. Now some people may need it so that I show every single step. So I'm going to go off to the side here to show every single step. This is 4x to the -4. This is the same as saying 4 times x to the -4. Now x to the -4 will be 1 over x to the 4th power. So if we take 4 times 1 over x to the 4th power, we could put a 1 under the 4, and it'd be 4 over x to the 4th power. And that's it, which is what we got here for number 11. Our next problem is 17. We have 3x to the -2 times x to the -3 times x squared. Now, what you notice here is we have multiplication, but if you notice, we have 3 x's that have the same base. So this would be 3x, and we would add these exponents, -2 plus -3 plus 2. Because when you multiply with the same base, you add the exponents. All right, so with that being said, this will end up being 3, -2 plus -3 is -5, plus 2 is -3. So it'd be 3x to the -3. And then we do not want to leave this with a negative exponent because the directions told us to write our results with positive exponents only. So this right here now looks like number 11. 3x to the negative 3, 4x to the negative 4. That ends up being 3 over x to the third. Now, our last problem would be problem 19. Problem 19, we have 4, a to the 0, b to the negative 4, all over negative 8, a squared, b to the negative 1. Now, like I told you all before, I would kind of separate this. So I put 4 over negative 8. I put a to the 0 over a squared. I will put b to the negative 4 all over b to the negative 1. Now 4 divided by a negative 8, we know would be a negative 1/2 because we could simplify that. Times a to the 0 over a to the second will be a to the 0 minus 2. Same base, you subtract the exponents. Then times, you have b to the negative 4 over b to the 1. It'll be b to the negative 4 minus a negative 1. So this will be a negative 1/2 times a to the negative 2 times, this will be negative 4 plus 1. So this will be b to the negative 3. So now we have negative 1/2 times a to the negative 2 is 1 over a squared times b to the negative 3 is 1 over b cubed. So your final answer here would be negative 1 over 2a squared b cubed. Now, that took care of section 2.3. Now we come here to section 2.4. Now with section 2.4, I'm going to do all of the problems for section 2.4. So it's 1, 3, 5, and 7. So number 1, it says simplify each expression by applying the properties of exponents. Write your results with positive exponents only. Now we have x to the third to the sixth. Now before I do this, I want to talk to you all about the property of exponents. Now we went through it, but I just want to formally talk about it. The first thing is, like we did on the other page, whenever you multiply the same base, so if you have x to the second times x to the third, whenever you have the same base, which happens to be the x's, you carry over the base and add the exponents. So this would be x to the fifth. That's the multiplication rule for exponents. Then you have the next, the division. If you add x to the third over x squared, same base, you carry the base over and you subtract the exponents. So it'd be x to the first, which is just x. Okay, next. We have multiplication with the same base, we add the exponents. Division with the same base, we subtract the exponents. And then we have something else called a power to a power. I'm going to do number 1 to demonstrate this. When you have a power to a power, you carry the base over and you multiply the exponents. So this would be x to the 18th power. So when you have the same base, you multiply. So that would be A. So now we come to B. We have 2x to the 5th squared. Now, if you notice here, in A, we just had the variable exponent into an exponent. So that was a little easier. But here we have a number multiplied to the variable to the exponent. So everything in here is taken to the second power. So it'll be 2 to the second power. And just to illustrate this, why is 2 to the second power? Because remember, 2 is assumed to be taken to the first power. So that's the same as saying 2 to the 1 times 2 power, and then it'll be x to the 5 times 2 power. So this would be 2 to the second power x to the 10th, which is 4x to the 10th. Okay, C. We have negative 3x squared to the third power. And we basically do the same thing here. So this will be negative 3, and I'm going to just leave it in the parentheses, to the third power, times x to the second to the third, which would be x to the 2 times 3. So negative 3 to the third power will be negative 3 times negative 3 times negative 3, which is a negative 27. And then this would be x to the 6. All right, now we go to D. We add x to the 4th to the negative 3. So take a power to a power, so it's 4 times negative 3, so it's x to the negative 12. Now we cannot leave that exponent negative, so when we have a whole base to a negative exponent, it'll be 1 over x to the 12th. The exponent becomes positive. Now we come here to E. With E, we have negative 4a to the negative 5, all taken to the second power. So we would take both of these to the second power to be negative 4 squared, put that in a parenthesis, and then it'll be a to the negative 5 times 2. Negative 4 to the second power is positive 16. So this would be a to the negative 10, because negative 5 times 2 is negative 10. And since a to the negative 10, that means this would go to our denominator. So it'd be 16 over a to the 10th. Okay, now F. F is very interesting. We have a squared, b to the negative 2, c to the third, all taken to the negative 4 power. Okay, so we would take those values, and since we have a power to a power, we will multiply.
You are now unmuted.
Okay, now we'll take these powers to a power. So this would be a to the 2 times 4, b to the negative 2 times negative 4. Oh, it's supposed to be negative 4. And then c to the third times negative 4. So this would be a to the negative 8, b to the positive 8, and c to the negative 12. Now, the b to the 8th will remain in your numerator. A to the negative 8 will go to your denominator as a to the 8th, and c to the negative 12 will go to your denominator as c to the positive 12. And that is your final answer for F. Okay. Now, we're going to move on to the next problem. Okay, now we will go to G. We have G, which is a negative x to the 6th to the third. This negative is on the outside of the parenthesis, so that would mean that this third power does not affect this negative sign here. So we would bring down a negative, and then this would be x to the 6th times 3. So this would give us a negative x to the 18th power. Now we go to H. We have H, which is a negative x to the third to the 6th power. Now, if you notice, everything in this parenthesis is affected by this 6th power. Now, we know if we write the negative sign 6 times, well, let me do it like this. This negative is really a negative 1. So I'm just going to show you how to do this here. So that means that this negative 1 would be taken to the 6th power, and then x to the third would be multiplied by 6. Negative 1 times itself 6 times would be positive 1 times. This would be x to the 18th, and then your final answer would be x to the 18th. Okay, now we go to number 3. Number 3, 3a, we have x to the 1/3 times x to the 3/4. When you multiply and you have the same base, you carry the base and you add the exponents. So now I was showing one of your classmates that you could use Desmos to help you add up these fractions. You could type in 1/3 and then I need a space here, then plus the 3/4. Now 1/3 plus 3/4 gives us this long decimal. We push this value here and it gives us the fractional exponent, which would be 13/12. Now they asked us here to simplify the following. Now, when they mention simplify here, they also want us to change this into a radical. So to change this to a radical, first of all, you see if you can simplify this fraction here. Well, you do that whether you change it to a radical or not. Okay, now that this fraction has been simplified, because you can't, the only thing 13 and 12 have in common is positive 1. So the denominator of this fraction becomes the index of this radical. The numerator of this fraction remains with the x that goes under the radical. So this right here would be your final answer. Your final answer is the 12th root of x to the 13th power. All right, now for 3b, we add x to the negative 1/3 to the negative 1/2 power. Now, when we take a power to a power, we multiply, we bring down our base. A negative 1/3 times a negative 1/2 is a positive 1/6. Now, we cannot simplify this any further. So this will end up being the 6th root of x to the 1st power, which is really just the 6th root of x. All right, now we go here to 3c. We add x to the 4/5 power divided by x to the 1/3 power. Now we know when we have the same base, we subtract the exponents. So we could put this right here in our Desmos calculator. 4/5 minus 1/3. Hit our fraction. So this would be x to the 7/15 power. Now as a radical, this would be the 15th root of x to the 7th power. So it's the 15th root of x to the 7th power. Now, we go here to number 5. It says f of x is equal to the square root of x minus 3. Determine each of the following. So we have a, which is f of 28. We'll substitute in 28 for x. So it'll be the square root of 28 minus 3. So this will give us the square root of 25, which will give us 5. So now we come here to b. We add f of 3. We're still using the same function. So f of 3 is equal to the square root of 3 minus 3, which is the square root of 0, which is 0. Now we go here to c. F of negative 1. We'll take the square root of negative 1 minus 3. So it'd be the square root of negative 4. Now your calculator, it will say error. Matter of fact, let me see what it says here in Desmos. The square root of negative 4, it has undefined. But what you are supposed to put is not a real number. because later on we're going to deal with the complex number system. So the square root of -4 actually does have an answer. It's just not a real number. All right, now we come down here to the last problem, which would be 7a and b. So 7, the length of time t in seconds it takes the pendulum of a clock to swing through one complete cycle is a function of the length of the pendulum in feet. The relationship is defined by t equals f of l, which is equal to 2 pi times the square root of l over 32. So this is the formula. All right, where L is the length of the pendulum. Now A, it says rewrite the formula using fractional exponents. So we had T is equal to F of L is equal to 2 pi. So if they want us to use fractional exponents, we got to get rid of this radical. Now, whenever you have a radical and there's no number showing in the index, it's assumed to be a 2. That's why it's called square root. So we would have L over 32. And remember, this is a 2. So we would take the reciprocal of this index, and that will become the exponent. So the reciprocal of 2 is 1/2, and that will become the exponent. So this is the answer for A. This is what they wanted for A. Now we do B. It says determine the length of the cycle in time if the pendulum is 4 feet long. So we had T is equal to, now what they want us to do here is assume that pi is 3.14 here. So 2 times 3.14 and then times the square root of L is 4 over 32. So T equals 6.28 times the square root of 4 over 32. Now, in usual times, you would simplify this fraction. But because we can use Desmos, we don't need to simplify the fraction. We can just put the fraction right under this radical. So it'd be 4 divided by 32. And if you notice, it's completely submerged under the radical here. So if we round the 2 decimal places, the time would be 2.22 seconds. And that will be it as far as the lesson for today. And have a nice day.